we leave the topic of nomenclature, there is a class of compounds that's really important to not only be able to recognize, but to know how to name. Now, this is a class of compounds that has a special naming scheme, and let's go over that right now. We're talking about the class of compounds called acids. So you might be wondering, what exactly is an acid? Well, there's actually quite a few acids that you may already know and love. This is just kind of a pH range. And on top of that pH range, there's a whole bunch of ordinary, normal household types of chemicals. And you'll notice on the one side of things, you have that little picture of a stomach, and then there's some different fruits and vegetables, all which we know are acidic in nature. Now, these items you may also notice have a very low pH. So we're specifically talking about chemicals that have a low pH. But how does that help us recognize when we have a chemical formula whether or not we have an acid? Now, there is an official definition that we will use, but just to be very, very clear, there are several different definitions of acid. But for our class, this is probably the one that fits us the best. But there are different definitions depending on what you're doing and what you're studying. So officially, we're going to say that an acid is anything that will dissociate in water to form H1+. Now, that's a heck of a lot of words. Let's make this make a little bit more sense to us. So for us, the easiest way that we're going to be able to recognize when we have an acid is we're going to look at the compound formula, and if it begins with H, with hydrogen, that's a great indication that we're dealing with an acid. Here is a list of some very common acids. Notice what they all have in common. All of them start with that letter H, indicating that it's an acidic compound. Notice also that there's usually an ion attached to them, a negative ion. But those ions can be in a whole bunch of different forms. That's what we're going to use to name an acid. So again, acids always have an anion, a negative ion in them. And these anions are all different. The type of anion that you have is going to determine how you name the acid. So let's start to categorize these anions. Well, first of all, you may have noticed that some of the anions have oxygen in them, and some of them don't. This is essentially our very first step in naming an acid compound. You need to decide, does my acid have oxygen or does it not have oxygen? Because there are two different methods for naming these two different types of compounds. Let's take a look at the easier one first, those that do not have oxygen in them. And we'll take a look at a friendly example that hopefully you already know, HCl. HCl's name is hydrochloric acid. So how do we get that name, and how can we apply this name to helping us name other acids? Well, you might notice that HCl, it has as an anion chlorine in it. And notice that inside of the name, we take chlor as part of that name. Everything else around it is what's going to stay consistent when we name other acids. We just need to be able to plug in the new root of those anions. So for example, when you're naming an acid like this, you're going to want to look up what it's attached to. This anion, without oxygen, is called chlorine. I'm going to take off the ending and shove that root into my naming system, hydrochloric acid. Let's take a look at another example. Maybe it'll make a little bit more sense. What about HBr? Now, because it doesn't have oxygen in it, I know it's going to be hydro something acid. Br's name is bromine. Take off the ending and shove the root of the word into my naming scheme. Hydrobromic acid. try another one. HI. That should be hydroiodic acid. Iodine, we take the INE ending off of it, and we call it hydroiodic acid. Well, what about something like this? Oh my goodness, it's a polyatomic ion. Ah, head for the hills. Still doesn't have oxygen in it. We can still name it according to this naming scheme. CN is called cyanide, so I would take off the ending and call this now hydrocyanic acid. No big deal. One more that I want to take a look at, and that's mostly because this is an exception to the rule. Now, sulfur compounds have been around for a really long time. So before there was a really good way of naming things, we kind of came up with names for things that had sulfur in them already. So sulfur compounds tend to be exceptions to naming rules, and this is no deviation from that course. So let's go through the normal naming scheme, and then I'll show you what I mean. So H2S, obviously, it would probably be hydrosulfic acid if we were going according to the rules. But this sounds really weird. Have you ever heard of sulfic acid? I know I haven't, but I have heard of something called sulfuric acid. So when we have sulfur, it's an exception to the naming rule, and you're going to have to add in the extra sound er. So instead of hydrosulfic acid, this is really hydrosulfuric acid. And you're going to see that no matter what type of compound that the sulfur is really in. It really does sound a lot better. Okay, so what about if my acid has oxygen in it? Well, the name of this particular acid, HClO3, is called chloric acid. Maybe we can figure this out by the naming here. Okay, so clearly the hydrogen is attached to ClO3. That's a polyatomic ion. So we're going to start off by writing the name of that polyatomic ion. And again, you're going to strip the ending off of it. We're going to go back just down to the root, chlor. Now we did a little something different here. There is a naming scheme that you do need to be familiar with. If you have an ATE ending on your acid, you're going to need to change that to an IC ending. And if you have an ITE ending on your polyatomic ion, you need to change that to OUS. So because chlorate had an ATE ending, I switched that out for IC and called this chloric acid. Now, I have a little phrase that might help you remember these naming schemes. It's really silly, though. Something I ate was icky. It might hurt us. It just at least helps you remember which endings are linked with which. Okay, so again, the IC ending came because I had an ATE ending on my poly. Okay, well, what about HNO3? Well, it has the polyatomic ion nitrate in it. Something I ate was icky. Let's replace that ending. So it's going to be nitro something. How about nitric acid? Done. Let's try another one. How about HNO2? Well, NO2 is the polyatomic ion nitrite. Get rid of the ending ite. It might hurt us. I'm going to replace that with an us ending. So this becomes nitrous acid, nitrous acid. One more, and again, this is going to be focusing on an exception to the rule. Dun, dun, dun. You have an acid that contains sulfur. Now don't forget, that means that we might need the extra syllable er to make it sound proper. Let's go through the naming scheme. SO4 is sulfate. Something I ate was icky. So I'm going to take off that ending. Sulf. That should be sulfic acid. I'm sorry that I have the wrong ending on there. But it still doesn't sound right. And remember, that's because sulfur is an exception to the rule. So we need to add in that extra syllable. Sulfur, and it should say ic, sulfuric acid. Sulfuric acid. We just needed to add in that extra syllable with sulfur. Now, unfortunately, sulfur is not the only element inside of an acid that you have to do this with. There's one more as well. So when you're naming acids and you're dealing with the element sulfur, whether it has oxygen or not, it doesn't matter. You have to add in this extra sound And the same thing now when you're dealing with phosphorus. You have to add in the sound or into the naming scheme to make sure that it makes sense. So you wouldn't say phosphic acid, you would say phosphoric acid. You wouldn't say phosphorus acid, you would say phosphorus acid. You're going to need some practice with these. I wish you very much so good luck. You may want to rewind to the beginning of the video and just watch it one more time because these can be tricky.